Today I am going to discuss to solve transportation problem, and this is a special type of transportation problem. Why special? A special in this case from factory 1 to warehouses B, you cannot shift any product. That means this road is infeasible. It may be due to the road blockade or due to any reasons. You cannot shift any item from this source to this destination. And another blockade is also there, that is from fourth factory or sources. You cannot shift any product to D warehouses. Again, I am briefing the problem. This is the transportation problem. Four factories supplying, producing products, and all the products has to be shifted to these warehouses. 5 warehouses are there, A, B, C, D, E. 5 warehouses exist here. The capacity of the factories are given here. First factory capacity is 200 units. For second factory, the capacity is this. For third factory, the capacity is 105, and fourth factory, the capacity is this. Okay. The requirement of the warehouses, for these warehouses, the requirement is this 110. For these warehouses, the requirement is this in this way. For these warehouses, the requirement is this. And the special condition in this problem is that you cannot shift any product from this factory to these warehouses. That's why it is shown blockade or no figure is given here. Okay. And from this factory, you cannot shift any product. That's why nil is given here, block is given. And these are the transportation cost, as I have already discussed in my several problems. This indicates from factory to, if you shift product to warehouse B, then per unit the shipment cost will be ₹9 in this way. I am explaining another one. If you shift one unit from factory 3 to factory D, the transportation cost per unit will be ₹70. Okay. So this is the problem you have to solve. Means you have to find out the best allocation, means the minimum cost transportation problem. Minimum cost you have to find out from which factory to which warehouses, how many products you will shift so that the conditions will be satisfied. That means your availability capacity and requirements will be fulfilled, but the total transportation cost will be minimum. This is the problem. How you solve it? Now I am going to start to solve it. Again, I am repeating the speciality of the problem is that this road is blocked. That means block means you cannot shift any product from this factory to this warehouse. Earlier in any problem you cannot deal this type of problems, and this is also a blockade, or you can say no product can be shifted from factory 4 to warehouse D. So I am going to start to solve this problem. This problem will be solved in 2 stages. First, you have to find out the basic feasible solution, and second stage you have to optimize it. Okay, I will use the VAM method, means Vogel'S approximation method, to find out the basic feasible solution. And for optimization, I will use the MODI method. MODI means modified distribution method. Okay. Acha, how will start? First of all, as these 2 points are blocked, that means you cannot shift any product from this source to this destination, what you will do, you will put one figure mathematically, say it is called big M. The value of M is significantly high. It is huge, high cost is to be allocated here, and say it is M. M is a value which is very high in comparison to any other cost. Similarly, because you cannot shift any product from this factory to that destination, to deal this situation, you have to put a very heavy, huge cost into this cell. Okay. And logically, as the cost is very high, therefore you see the allocation will automatically be eliminated. The process is such that it will be automatically eliminated. Now I am going to start for the next step. I already mentioned earlier that first you have to check whether it is a balanced problem or not. So first you have to put the high cost M to the infeasible block or cell infeasible root, that is M, and after that you have to check it is a balanced problem or not. Balanced problem means the total availability or capacity. The total availability, or you can say capacity and the total requirement is same or not, that you have to check. Now if I add this, the total is 710, and that is the capacity is 710 units. The requirement, if you add all this, the requirement is 710. These are same. That means it is a balance problem. If it is not a balance problem, then you have to build in different way. First you have to add dummy, as I have already discussed in my separate videos. Okay, but in this case you have to face no problem. It is a balance problem. Now I'm going to start application of HAM to find out the basic feasible solution. So how we do it? First, row wise, to find the lowest cost. For the first row, the lowest cost is 8 and the immediate lowest cost is 13. What is the difference between the lowest and immediate lowest? The difference is 5. No, note down here, 5. This is the process of VAM. For second row, the lowest cost is 9 and the next immediate lowest cost is 10. The difference is 1. For third row, the lowest cost is 12 and the immediate lowest, for the third row, the lowest cost is 11 and the immediate lowest cost is 12. Because the difference of the lowest and immediate lowest is 1. And for the last row, I'm writing 8 in this place. The lowest cost is 10 and the immediate lowest is 13. That's why the difference is 3. Same process you have to do for column 1. For first column, the lowest element is 10 and the immediate lowest is 13. That's why the difference is 3. For second column, the lowest is 9 and the immediate lowest is 11. The difference is 2. For third column, the lowest is 12 and the immediate lowest is 13. The difference is 1. And for this column, the lowest is 8 and immediate lowest is 17. That's why the difference is 9. And for the last column, the lowest is 10 and the immediate lowest is 15. That's why the difference is 5. In this way, we'll note down all the differences. 3, 2, 1, 9, 5 and 5, 1, 1, 3. Okay? And out of these differences, you have to find the highest differences. This is the highest differences. Why we are doing this in HAM method? Actually, this is nothing, the difference is nothing of penalty cost, you can say. And for that reason, if you put where the highest penalty is highest difference of the highest and lowest and highest cost, then you will get maximum advantage. That's why we are selecting the highest difference. And where we will put the allocation? And we put the allocation at the lowest cost places. We have to put the allocation here. The allocation rule is same as northwest corner rule, matrix minimum method, column minimum method, like that. So the minimum of this will be the allocated amount, that is 200. The minimum of this means out of 200 and 230, the minimum one is, so you have to put the lowest one, because you can maximum send the lowest one. You cannot send here, you cannot put here say 250 or 210. Why you cannot put 210? Because your availability is 200. That's why you cannot put more than that in this one. And you cannot put more than 230 also, because the requirement is 230. So out of the feasible is the lowest one you will put. Okay, तो दोनों का जो मिनिमम है उसी को यहाँ पर पुट कर देना है. तो फर्स्ट रो का बैलेंस क्या रहेगा? इज देयर एनी बैलेंस? नो, दिस इज द जीरो बैलेंस बिकॉज द एंटायर कैपेसिटी availability has been allocated here. And what is the remaining quantity required? 230, and you have already allocated 200. That's why 30 units. So first stage is over. Okay. Now just keep note down it here. This is the first allocation. So first allocation is from source 1. The whereas you have to ship 200 units. Now next, as the requirement of this has been completed, filled, so you can remove this row. You can remove this row, and that's why just revising on the same table I am doing it for getting the space. You will note down in your copy. तुम्हारा copy में इसको note down करके रखना है, because the final table जब final हो जाएगा तो we have to put it. Okay. So now we need not to allocate it, that's why I have erased it. Now this is again A, B, C, D, E. समझ में आया जो इसको आउट कर दिया, इरेज कर दिया, क्योंकि उसका कोई जरूरत नहीं, ऑलरेडी उसका सारा कैपेसिटी जो है एलोकेटेड होगा. अच्छा, तो ये डिफरेंस तो सेम रहेगा. अगेन द रो वाइज यू हैव टू फाइंड आउट द डिफरेंस ऑफ हाईएस्ट एंड लोएस्ट. Okay, the difference is lowest and immediate lowest, that is the lowest is 9 and immediate lowest is 10. That the difference is 1. It will not change because row has not changed here, that's why it will be remain same, but it will be changed, that's why I am erasing it. In this place it will be 30. The remaining demand is 30. Okay? And always you can check it, the both side will be same. If you add and check it, then again you will find your capacity and requirement will be same. If you add this, then you can check the both sides will be same. Though it is not required to check, but for better control you can check it. 175 plus 105 plus 230. 230 is equal to 510. This is 510 and you can check it, that is also 510. 110 plus 90 plus 120 plus 30 plus 160, 510. This is also 510. As it is a balanced problem, that's why it will be always balanced. So row wise, the difference of lowest and immediate lowest is already calculated. Now column wise, for first column, what is the lowest? Is 10 and the second lowest is 40. That's why the difference is 4. For second column, the lowest is 9 and immediate lowest is 11. That's why it is 2. And third, the lowest is 12 and immediate lowest 30 is 1. And this is lowest and immediate lowest 26. That's why what is the difference? 9. And this is lowest is 10 and immediate lowest 50. That's why this is 5. In this way, you have to calculate the lowest and immediate lowest. Now find out the highest difference. These are the differences, and which one is the highest? This is the highest. This is the highest difference. 9. That means you have to allocate in this column. You have to allocate in this column. How much you will allocate? 30. You have to allocate. Just add marking. Sorry, lowest. You have to allocate to the lowest cost element. You have to allocate here. So out of 30 and 105, which is the lowest, minimum is out of this. The minimum is 30. That's why you have to put 30, and the balance requirement is 75, and this is 0. That means the second allocation will be here, D has been fulfilled. Okay, that means you can say the solution 3 and D. 3D, the allocation is how much? 30. You will just note down it. Now again, I am erasing this just to, you will do in your copy a separate unit, separate table. As space problem is here, that's why I am doing on the separate. Okay, so you have to put another column, that is E. This is D, or you have to A, B, C and E. E means 10, 15, 10, 15 and 70. And the quantity remains how much? 175. This is 75 and 230. 175. And again you can check it, it will be balanced. And the difference of the lowest and immediate lowest will not change because these figures remain same. You can check it also. The lowest is 10 and the immediate lowest is 40. The difference is 4. Column wise, it is available. It was also available, though I have erased it. That's why I am doing it again. 10 and 15. That is 5. And you have to write it 5. And the quantity is 160. The quantity will be 160. And this is the E. Go down E. And for row wise, first row, this is the lowest and immediate lowest. The difference is 1. And this case, the lowest is, what is 11? The immediate lowest is 0. That's why this is also 1. And for the last row, the lowest is 10 and the immediate lowest is 13. That's why it is 13. Now find out the maximum difference. Out of this, the maximum difference is this. And where will the allocation? The allocation will be at the lowest cost. The allocation will be here. How much? The minimum of this and this. What is the minimum of this and this? 160. 160. That's why it will be 0 and it will be 15 only. 15. That means this allocation is 2E. That is 2E. The allocation will be 160. We have to put all these figures. Okay. Now this is completed. Nothing is 0. That's why I am erasing this and the remaining table will be this. Again, I am repeating, you have to do this in separate table in your page. Now, just to save the space, I am doing on the same table. This is 50 and this is 75 and this is 230. 230. Okay. So the difference will be the calculation lowest and immediate lowest. This will not change as the column figure remains same, but these will be changed. What is the lowest? Lowest 9 and immediate lowest is 14. That's why the difference is 5. If the lowest is 11, immediate lowest is 12. That's the difference is 1. If the lowest is 10 and immediate lowest is 21. Sorry, immediate 30. That's why the difference is 3. Now check the highest difference. Out of this, the highest difference is this. That's why your allocation will be here. Your allocation will be here. How much will be your allocation in this place? What is the value? 50. 50 and 120. Sorry. What is the highest difference? Sorry. Highest difference is 5. Highest difference 4, 2, 1. And you have to put in this row. And where you have to put the lowest cost is not this. The lowest cost is this. Lowest cost is this. And how much it is? 50 and 90. And out of this, the minimum one you have to take 50. 50. That's why this will be 0. The balance will be 0 and this will be how much? 75. 80 and 75. In this way, that means this row has been fulfilled. The allocation is 2B. 2B will be 50. 2B will be 50. Now, erase this. Erase this. So, sorry, erase this. Instead 50, not this. Horizontally, you have to erase it. Now, I am writing the revised table. The remaining table will be this. 15 has been completed, 75 revised. That means A, B, C. The table will be like this. A, B, and C. And this is the 3 and 4. The remaining for this 25. 25, 11 and 12. This is 11 and 12 and 10, 21, 10, 21 and 30. Availability is 75, 75 and 230, 230. And here 110, this is 70, 95, 90 and 120. You can check that the total of both sides will be set 105 and you say 0 to 35, 110. This is 75. That's why I'm checking. That will be 75. You check your previous table. Your previous table, that is 93, 20, 15. Sorry, 75 to 30. That is 300. 230 is 305. And if you are 110, 75, 120, it is 305. Okay, that will be this. Yes. Now you have to allocate. Again, calculate first row wise lowest and immediate lowest. That is 1. 12 minus 11 is 1. And this row 10 and immediate lowest is 13. That's why the difference is 13, 3. And lowest and immediate lowest, that is 15. And in this case 10. And in this case 1. 12 and 13. That is the highest difference. Highest difference is 15. That's why you have to allocate the lowest cost. Is the lowest cost. In this column, you have to allocate 110 and 230. The lowest is 110. That's why it is 0. And this is 110 means 110, 120 is the remaining quantity. It is the allocation will be 4A. This is 4A is 110. 110. Okay. Now, this will be fulfilled. That's why I'm erasing this this part is raising, A is raising 3 and 4. 3 and 4. This is 3 and 4. And you can check both sides, and that this will be 120. It will be 120, and this will change. Let's check to 195, 195, and this is something wrong. B and C. B is 75, 75 and 120, and this is 195, and this is also 125. Now I will calculate the difference between 2, 14 and 8. This is 8, and this is the difference 21 minus 11. That is how much? 10. 10, and the difference of this is 1. And what is the highest difference is this. The allocation will be here. How much? 75. 75. This is 0, and this is also 0. That means both sides only the remaining 120. That's why the last one definitely will be 120. Because the last element will be this, and 120 remains, and this. That's why this is also 0. What is the allocation? 3B will be 75, and this is 4C. 4C will be how much? 4C is 120. 4C is 120. In this way, you will get the basic feasible solution by Beham method. This is the first step, and after that you have to apply the Modi method. Okay. Now that means what will be the basic feasible solution, and writing the complete table with the allocation. So using this part. Okay. This is 4 by 5 problem. 4 by 5 problem. 4. This is the basic feasible solution. 4 by 5 problem. 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay. The factories 1, 2, 3, and 4. This is factories or warehouses. Warehouses A, B, C, D, and E. The transportation cost 13M, 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 31.8, 31.8, and 20, 20. And next 49, 49, 17, 17, 26, 10, 10, 25, 25, 11, 25, 11, 12, 17, 15, 12, 17, and 15, and 10, 21, 10, 21, 13, M, 13, M, and 17. And what is the basic allocations? The basic allocations will be 8, 200, 200. This is the basic allocation which I have already done. And next 9, this is 50, 50, and next this is 2E. 2E is 160, 2E, 2E is 160, 2E is 160, and then 3B is 75, 3B is 75, 3B is 75, and then 3D is 30, 3D is 30, 3D is 30, 3D is 30. This 4A is 110, 4A is 110, 4A is 110, 4A is 110, and next 4C is 120, 4C is 120, 4C is 120. We have already noted earlier, and 4C is 120. That's all. And you can check it. If you add, then you will see the total capacity and total requirement has been fulfilled. You can check also. If you check, then you will see this is 200. 200 watt was the first table given, and this is 175, 175, and this is 120, 120. This is 120. This is 120. Sorry, 105. This is 105. the original problem, 105, and this is 230. 230, and vertically if you add, this is 110, and this is 90, and this is 120, and 20, 230, 130, 230, and this is 160. So this is your basic feasible solution by Ham method, and you can also find out the transportation cost by this method. What will be the transportation cost? Is 208, 200 into 8 plus 215 into 9, 15 into 9 plus 160, 160 into 10 plus 75 plus 75 into 11 plus 30 into 17, 30 into 17 plus 110 plus 110 into 10 plus 120 into 30, and that will be the total cost by Ham method. But this is not the guaranteed minimum, and for that purpose you have to proceed by body method, and after calculating the cost you can check it how much it is. This is the total cost for Ham method. Okay, if you want to like to calculate, then you can calculate also, but it only take time. Okay, I am to doing it also. That is 200, 1600 plus 15 into 9, 15 into 9, 15 into 9, now 1600 plus 75 into 11 plus 30 into 70, 30 into 70 plus 1100 plus 120 into 30. That is total will be 7330. The total cost will be 7330. But this is not the guaranteed minimum. We have to find out the minimum cost. We have to find out the allocation for which the total cost, transportation cost will be minimum. That's why we have to proceed for the Ham method. Modi method. So up to this it is Ham method by which we have found out the basic feasible solution. Okay. The next stage. After this is one video, and for finding the minimum cost, transportation cost by applying body, I am doing a separate video. Otherwise, the video will be very bulky and maybe problem to upload different technical problem. I think you have understood that. Again, I am repeating, this problem has been solved in two stages. Have to be solved in two stages. First, to find out the basic feasible solution by Modi method, and then you have to find out the optimum allocations, the minimum cost by Modi method. The up to first stage, that is Ham method, is over. In this way, you have to find out the basic feasible solution. Okay, thank you.